Hello everyone, and welcome. You're going to want to sit down for this because some huge news has just landed in the world of science, and I mean genuinely world-changing stuff. It's like we've just been handed a brand new type of Lego brick, one that could let us build a totally different future.
And here it is. The 2025 Nobel Prize in Chemistry has officially been awarded for creating what the committee is calling molecular constructions. So what's the big deal, Yar? What did these scientists actually build that's got the entire scientific community buzzing? Well, stick around, because that's exactly what we're going to break down in today's explainer.
All right, here's our game plan. First, we'll look at the discovery itself. Then, we'll check into what I love to call the molecular hotel to see how it all works. We'll meet the brilliant minds who designed it, see how it could solve some of our biggest global problems, talk about the challenges ahead, and wrap up with India's role in this whole revolution. Let's do this.
Right, let's kick things off with the discovery. This Nobel Prize isn't for some flash-in-the-pan idea. Oh no, this is for decades of hard work by three incredible scientists who created a whole new class of materials. We're about to meet them and see how each of them contributed to creating what we now call metal organic frameworks, or MOFs for short.
Okay, time to get into the science. Now, I know metal organic framework sounds kind of heavy, but trust me, the basic idea behind it is super elegant. Just think of it like building a hotel, but for individual molecules. We're going to see exactly what these MOFs are and how they're built one molecule at a time.
So what on earth is a MOF? Well, at its core, it's a crystalline compound. That just means all its atoms are arranged in a perfectly ordered, repeating pattern, not just a random mess. But the magic lies in their huge internal cavities, or pores. And you can see why the molecular hotel analogy works so well, right? These are like millions of tiny, perfectly designed rooms just waiting for guest molecules to check in.
So how do you build one of these tiny hotels? This is where the sheer genius of Omar Yaghi's reticular chemistry comes into play. It's all about precision. You start with metal ions. Think of these as the joints, or the cornerstones of the building. Then you add organic molecules, which act as the struts, the beams that connect those corners. And when you mix them, they self-assemble into this amazing, rigid 3D network full of holes. You're literally stitching molecules together to build a structure from the ground up.
Now, to really grasp the scale we're talking about here, look at this number. The internal surface area, all those tiny rooms added up, is just unbelievable. Let's take a famous one, MOF 77. A single gram of this stuff, okay? A pinch of powder you could hold on your fingertip. It has an internal surface area of 5,640 square meters. That is nearly the size of a football field. A football field's worth of space packed into a pinch of dust. Just think about what you could store in there.
And this is why MOFs are such a massive deal. I mean, we've had porous materials before, right? Things like zeolites or the activated carbon in your water filter. But just look at this comparison. Zeolites have fixed pore sizes. You get what you get. Activated carbon is just a chaotic, disordered mess. But MOFs, they're perfectly ordered. And this is the key. They are precisely tunable. You can design the rooms to be any size or shape you want. And the surface area? It's just on another planet. That level of custom design is what makes them a revolution.
But you know, a breakthrough like this doesn't just happen overnight. Behind all the cool science is an amazing story of human vision, of pure persistence over decades, often when the rest of the scientific world thought they were wasting their time. It's a journey that really started long before anyone was ready to listen.
This timeline shows you how the whole thing came together step by step. It all started back in the 80s with Richard Robson just dreaming up the basic concepts. Then in 92, Susumu Kitagawa takes a massive step and actually builds the first 2D version. And finally, in 95, Omar Yaghi hits the jackpot. He creates the first truly stable, super porous 3D MOF. It was that decade, with these guys working independently, that just blew the field wide open.
Let's start with Richard Robson. I think of him as the visionary. He was a pioneer in a field called crystal engineering. And way back in the 80s, he looked at the perfect symmetrical structure of a diamond and thought, hey, what if we could build new materials like that? His first attempts were pretty unstable. They'd often just collapse. But he saw the potential, he saw the future, and he laid the intellectual groundwork that everyone else built on.
Then you have Susumu Kitagawa, the innovator. He's the one who made the first working 2D model and proved that yes, gases could actually move in and out of these things. But his real genius was his foresight. He imagined flexible MOFs, materials that weren't just rigid boxes but could actually breathe and change shape. He still dreams of using them to capture CO2 and turn it into something useful.
And finally, Omar Yaghi, the master architect. If Robson had the dream,
Yaghi built the skyscraper. He literally wrote the rulebook for building these things with his reticular chemistry. He's the one who cracked the code to make them super stable and permanently porous. And he didn't stop there. He went on to pioneer things like molecular weaving, turning this from a cool idea into a powerful, real-world platform for building new materials.
So, we've met the architects, we get the science, but what's the point? Why does this matter to you and me? This is where it gets really, really exciting, because the applications for these molecular hotels connect directly to the biggest problems we're facing on this planet.
First up, gas storage. Thanks to that crazy internal surface area, MOFs can pack gases in way more densely than a standard compressed gas tank. This is a massive deal for clean energy. Imagine a hydrogen-powered car with a fuel tank that's lighter, safer, and holds way more fuel at lower pressure. Or being able to safely capture and store toxic gases from factories. MOFs make all of that a reality.
And for the environment, this is where things get truly transformative. The big one, of course, is carbon capture. You can design a MOF where the rooms are the perfect size and shape to snatch CO2 molecules right out of a smokestack. But it's not just about the air. You can also tailor them to pull specific pollutants out of water, or to precisely separate gases, like pulling pure oxygen straight from the air around us.
Now that's all great for big industrial problems, but let me ask you this. How can a fancy powder help with something as basic as finding clean water to drink, especially in a place like a desert?
The answer is absolutely mind-blowing. They can literally pull water out of thin air. You see, even in the driest desert, there's always some humidity in the atmosphere. Scientists have designed MOFs that act like super sponges, soaking up that water vapor during the cool night. Then, when the sun comes up, a little bit of its heat is all it takes to make the MOF release it as pure, liquid drinking water. A small, simple device could produce liters of clean water every day. In a desert. This is revolutionary.
And the list just goes on and on. The same properties make them amazing for catalysis, speeding up chemical reactions. You can load their pores with medicine and design them to release it only when they reach a specific part of the body. You can make them change color in the presence of a certain chemical to create super-sensitive sensors, and the potential for better batteries and fuel cells is just enormous.
Okay, so it's really important to keep our feet on the ground here. As incredible as this all sounds, it's not magic. There are still some pretty big real-world challenges that scientists are working on right now before we start seeing these molecular hotels everywhere.
Yeah, this slide lays it out perfectly. On the one side, we have the hurdles. We need to make sure they're stable for years, not just days. Some of the raw materials are expensive, and figuring out how to make this stuff by the ton, not just by the gram, is a huge engineering problem. But on the other side, the future is so bright. As we get better at designing them, their performance will just keep getting better, and we'll figure out smarter ways to integrate them into the tech we already use. So, with all this global excitement, you might be wondering, where does India fit into this picture? Well, the great news is we are not sitting on the sidelines. Researchers all across India are jumping into this field and focusing on solving problems that are uniquely important to us. And you can see that focus right here. Indian scientists are working on MOFs for carbon capture to help us meet our climate goals. They're developing better hydrogen storage for our clean energy mission. And, of course, a huge area is water purification, tackling the very real water quality challenges we face in so many places. This isn't just basic science. It's research with a real purpose for our nation. You know, in the end, I think this quote from the Nobel Committee says it all. This prize wasn't just for making a new material. It was for giving chemists a whole new way to build our world. It's a brand new toolbox for designing matter with absolute atom-by-atom precision. And that is a fundamental shift that's going to ripple through science for decades. So there you have it. From a new type of Lego brick to molecular hotels that can literally pull water from desert air, the world of MOFs is just getting started. We've really only scratched the surface today, but if you're as excited about this as I am and you want to dive deeper, we've got you covered. Just head over to our website, the link is waiting for you in the description below, where we've put together some detailed notes and a really handy quick revision mind map on MOFs. Thanks so much for joining me.